So thank you very much. So I'm Chris Calam from Thermo Fisher Scientific, and I'd like to talk to you about my company and portable XRF as well. So with greater than $35 billion of revenue, we're often the company of choice that many companies want to partner with. With $1.5 billion of R&D revenues, then that's enough really to keep us ahead of with cutting edge technology. So we sell a range of portable XRF for many different applications. From the DXL that you see there, which is a small benchtop instrument, to our flagship product, the XL5 Plus, which is typically used in exploration, in mining exploration. So we cover the full range of mining applications, from early stage exploration through to grade control across a wide range of mineral types. So XL5 Plus is our flagship product that typically we'd use for exploration. But if you're doing something like, something relatively simple, like grade control of a base metal, then something like an XL2 silicon pin instrument would be more than sufficient for the application. So what's important in an analyzer when you purchase one? Well, typically most customers want high precision. They want something which is very sensitive and fast, but they also want something at a relatively low price. So it's about creating the combination of those two things together in a package that delivers on the performance that is fit for purpose for them. So when we look at things like performance, customers and the market is demanding something which is accurate, something which is fast and sensitive. But typically, you have to set out your objectives about what you want to achieve for the application that you're working on, and that will dictate what level of sample preparation you may put into your samples, how you present your sample to the analyzer, whether the sample is just doing rock outcrops or RC chips, or whether you're grinding your sample and pressing it into a press pellet to really optimize the performance to get near lab quality data. So the XL5 Plus delivers 5 watts of, utilizes the 5 watt X-ray tube, delivering 500 microamps of power at that low end to optimize our performance, our limits of detection for magnesium, alumina, silica, sulfur, and phosphorus. And if you look at the chart here, it demonstrates that roughly we've had a factor of 2 increase in limits of detection between the XL5 Plus and some of our previous instruments. So that's partly down to the increased current that we're putting into the analyzer, but also as we've moved to graphene windows on our instruments as well. So the sample prep we do is often determined by what are our objectives for the application. So if you're working in exploration, typically you're just looking at delivering no sample preparation at all, and you're looking to just analyze the soil as it is. So we're really looking for anomalies in the surface. So if you're mining for copper, for instance, if you're exploring for copper, then if the base level is 5 to 10 ppm and you're measuring something at 1,000, then you're not really looking for accurate analysis at 1,000 ppm, because you don't really care how accurate that data is. All you know is your base level is here, and you're measuring an anomaly which is significantly higher than your base level. But if you're a refiner, then clearly you want to optimize your data. So you have to do the same kind of sample preparation that you would do in a lab. And we have some field portable tools to facilitate that sample preparation as well. So those are grinders and crushers, but also presses as well, to press that sample with the same force from sample to sample. And clearly, the form of the sample that we see, we have to take into account, the environment as well. So if our sample is wet, then that will start to absorb the signal as well. So we have to take that into account. So maybe there is some drying that we have to take in, that we have to utilize. So when you work through what your objectives are, really you need to refine those objectives and set up a process that you create your standard operating procedure. And you need to ensure it's implemented across the company. So within that SOP, maybe fine-tuning the calibration with some local reference samples. It'll be about understanding how long you need to analyze for. Because, are you looking at low concentrations, in which case your analysis time will be significantly longer than if you're looking at elevated concentrations of elements. What sample prep will you do, if any? What QA/Q samples will you run as part of your quality control process? So typically in most SOPs, though, you will have a set of QA/QC standards you run first thing in the morning, and then maybe you replicate on a 2-hour basis to ensure that your results in between those samples are good quality data. And you need to create some decision criteria because often with portable XRF we're still sending some samples out for external assay. So what is the criteria for sending those samples out for external assay? When we get those results back from the external lab, we're clearly comparing it with our portable XRF data, and are there any differences? If there are, what is the reason for those differences? Sometimes you'll find that when samples are sent out for ICP, that there is an incomplete digestion. So understanding which elements digest better than others, so that if there are differences, you understand them and can take those into account. And if there are lots of differences, then you would need to readjust that standard operating procedure to take those into account. The key thing is ensuring that your data generated is of the highest possible quality, it's fit for purpose, it delivers on the quality objectives that you've set initially, and it's about having confidence in that data. And if you plan for success and you set yourself up for success, you're likely to achieve that. So these are the sample prep tools that we use. So if you're on a pit face, on our underground, then we'll use some of the rotary samplers to make some strike cuts across the pit face to collect that data. And then we have some other blade grinders and pelletizers in there as well. So XL5 Plus, we're generating that data. We need to export that data and get it into our geochemistry packages. And we have Bluetooth, USB, and Wi-Fi for enabling that transfer of data. So that's talking about what we've been doing today. What about the future? Well, one of the things I've done a little bit of work on is looking at drones. Drones are used extensively already in the mining operations. So we're looking at, can we utilize portable XRF inside or on top of a drone? And if you look at what drones have been used for, it's about improving safety in the field, it's about managing assets, and it's also, drones have been used to integrate different payloads onto them. So one of the first things we did was to lightweight the instrument because, our handhelds are great for utilizing in your hand, but if you're attaching that to a drone, then there's a lot of stuff like the external plastics you can remove. We have a battery in each of the devices, so let's utilize the batteries from something like a quadcopter into the niton analyzer. We mount it for effective positioning. Typically we have to work out where we want to fly that drone to take the analysis, and typically we'd use some historical data to determine where those locations would be, and typically those locations are either dangerous places or areas where it's very difficult to access. So when you fly your quadcopter in, clearly you want to alight onto an area where you can do a decent analysis. So we've been using some artificial intelligence to work out where does a quadcopter land so that we can get some really good quality data when we arrive there. And you have to think in your operating procedures about when you generate that analysis, then what does that analysis trigger? Is it a barren area that's not really interesting data, or is it an interesting data where you're generating some anomalies, where you're measuring some anomalies, and you want to then move out from there and trigger some additional analysis very close by. And clearly, when we're using a drone, there is no sample preparation. So there is a limit to what you can get from that data. But the benefits are we can access we can get to access areas which traditionally have been quite difficult or dangerous to engage with. And we get a more complete data set. And it also speeds up the process. So in summary, XL5 Plus delivers really high quality data. Used appropriately, can really help in the exploration and mining stages of your operations. Thank you.